Welcome to BKW Physics. I'm Mr. McConnelly. We're going to talk about wave velocity today. And I have a note sheet for the students in class to kind of follow along. Now, if you go back to a long time ago, our first physics equation, we said velocity was distance divided by time for something that was moving along and not accelerating. Well, if we take that concept and we kind of apply it to what we're doing in waves, when we look at waves, how do we measure distance on waves? From yesterday's lesson, you will recall that the distance was measured in wavelengths, which was that new symbol above it. And when you measure time, when you're talking about a wave, we called it period. And again, it looks like a T, but it's a tau. And tau means the period or the time for one wave to go by. So what we've now kind of created is our new equation that enables us to find the velocity of a wave. You divide wavelength divided by the period of the wave. But I want to throw in one more piece here. You'll also recall that the period was 1 over the frequency. So if I plug that in, I have the wavelength over 1 over the frequency, or that's sloppy when you have complex fractions. So it could just be the frequency times the wavelength. So these two equations, velocity is wavelength over period, or velocity is frequency over wavelength, they're really the same, or they're equivalent equations. It's just if you're given the frequency, obviously it's easier to use that one, and if you're given the period, it's easier to use that equation. Now, just speaking a second about wave velocities, there's a couple velocities that really you need to know are in your reference table, and you need to be able to find them quickly. The velocity or the speed of sound. So sound waves travel fairly quickly, but as you think about it, they must not be that quick, because if you watch someone a long distance away, I can see from my classroom window, I can see the elementary playground. If I watch a kid banging a rock against the elementary playground set there, I will see the kid hit with my eyes, and then I will hear like a 1 Mississippi later. It won't line up. It'll be like bang, bang, bang. The timing will be off. So the speed of sound must not be that fast. It really isn't. It is, according to the reference table, 3.31 E2 meters per second, or 331 meters per second. So in 1 second it will travel 331 meters, which when you think about it is not really that fast. Because in comparison, the velocity of light, and I'll put a little note underneath, it's actually all electromagnetic waves. That'll make more sense later, but right now let's just refer to it as the speed of light. The speed of light is so much faster that it's actually 3.00 E8 meters per second. So the speed of light, for all intents and purposes, as we see it day to day, is instantaneous. When I see something, it's so fast that it's basically there as soon as the light is emitted. So for today, physics.